Alright, the second issue we are going to look at is signal handling. So what is a signal? A signal is used to notify a process that a particular event has occurred. So the classic example I will give is your wait system call. In a previous segment we discussed how when a parent wants its child to terminate, it asks the child to terminate and then it issues something called a wait system call. Once the child has been terminated, the exit status is notified to the parent by means of this wait system call. So that is how the parent process comes to know that the child termination has happened. That's an example of a signal. A signal is any notification which tells a process that a particular event has happened. So a signal is generated by the occurrence of an event. The signal is delivered to the process. Once the signal is delivered, it must be handled. And by handling a signal, we mean that the process which receives the signal has to react to it. So when the parent process gets to know that the child has terminated, the parent will go on and terminate itself, for example. So that is how a signal is handled, by reacting in some way to the notification you receive. How it is handled? It can be some default signal handling mechanism or some user defined mechanism. So that's the basic idea of what a signal is. But what is the problem or what is the ambiguity in signal handling which occurs because of multi-threading? So handling signals in single-threaded programs, it's straightforward. So when you have a process and it is just one thread, there are no divisions, it is straightforward. It is one process, it waits for a signal, it gets the signal, it does whatever it has to do. But when there are multiple threads in the same process, where should the signal be delivered? So do you find out which thread this signal is applicable for and then deliver it only to that thread, which might be time consuming and costly? Do you deliver it to all the threads, which might be unnecessary, or it might sometimes be unsafe also? Some threads might not, ideally should not be allowed access to some information. In that case it could be dangerous to deliver the signal to all the threads. Do you deliver that signal to specific threads alone? If yes, how do you choose which threads? Or do you assign one thread to receive all signals and then inform the other neighboring threads as and when applicable? So again you see that we saw one problem. There are multiple threads for a process and a signal has to be delivered to that process. Which thread do you deliver it to? This was the problem statement. Again you see that there are at least 4 different ways of handling the problem. Again, we are not going to discuss which is good, which is bad, which is sensible, which is not. These are different ways. There are other ways, and what actually happens inside the system, as always, depends on the OS architecture. We are just taking a look at the various scenarios, and this is one of them.